Welcome back to the Deep Dive. Today we're jumping right into a huge topic for the future of safe AI.
That's right. We're talking about privacy in large language models.
And specifically, we're going to unpack Vault Gemma 1B. It's a major release from Google that tackles AI's pretty serious data leakage problem using something called differential privacy.
And it is a serious problem. The core risk here is that LLMs are trained on, well, basically the entire internet. And they're really, really good at accidentally memorizing sensitive data they see.
You mean things like PII, personally identifiable information.
Exactly. They can just spit it back out verbatim. It's a huge privacy flaw.
So these incredibly powerful models can accidentally become these giant leaky photocopies.
It's a pretty good analogy, yeah.
And the solution, according to our sources, is differential privacy, or DP. Why is that considered the sort of mathematical gold standard here?
Because it is provable. I mean, DP isn't just a suggestion, it's a rigorous mathematical framework. It fundamentally limits how much any single training example can influence the final model. It gives you a guaranteed mathematical bound on information leakage.
So it's an actual proof, not just a promise.
Precisely.
All right, let's get into the big distinction Vault Gemma is making. We hear a lot about applying DP during fine-tuning, but the argument here is well, it's not enough.
It's really a false sense of security. The model sees most of its data during that initial massive pre-training phase.
Right, before any fine-tuning even happens.
So if the model has already memorized PII during pre-training, applying DP later doesn't just magically erase that memory. The vulnerability is already baked in.
Especially for open-weight models where anyone can get their hands on the weights.
That's the real danger zone.
Which brings us back to Vault Gemma. What they're doing differently is providing an end-to-end privacy guarantee, right?
Yes, they trained the model fully with DP from the very beginning, from the pre-training phase on the same massive 13 trillion token data set as the Gemma 2 series.
And they delivered a very specific, measurable guarantee.
They did. For Vault Gemma 1B, which is now the largest privately trained open-weight model out there, they have a, let me get this right, a epsilon lek 2.0 delta lek 1.1 E10 sequence level DP guarantee.
Okay, that is a lot of Greek letters and exponents.
Yeah.
For those of us who, aren't reading theory papers for breakfast, what does an epsilon of 2.0 actually tell us?
Think of epsilon as the privacy budget. The lower the number, the stronger the privacy. A 2.0 for a model this big is actually, it's a very robust guarantee. And delta is just the tiny, tiny chance that the privacy could theoretically fail.
So it's the mathematical proof that you're capping the risk.
Exactly. And the empirical proof is even clearer.
What did they find when they tested it for memorization?
Well, the non-DP Gemma models, they had detectable memorization. But Vault Gemma, it showed absolutely no detectable memorization at all.
Wow. So it worked.
It worked. The DP approach, when applied from the start, it solved the leakage problem.
But there's always a trade-off in AI, isn't there? The sources talked about a utility gap. What did they have to sacrifice for this level of privacy?
Utility. Performance, basically. DP works by adding mathematical noise during training to protect the data points.
And that noise, while it protects privacy, it must hinder the model's ability to learn perfectly.
It does. It's just the inherent cost. So while Vault Gemma is really impressive for a private model, its actual performance is comparable to non-private models from about 5 years ago.
Like a GPT-2 class model?
Yeah, something like GPT-2 1.5b. So that shows you the gap that researchers are still trying to close.
To even get this to work at scale must have been a huge engineering challenge. I saw mentions of new scaling laws and something called truncated Poisson subsampling.
Right, because DP training is just incredibly slow and expensive. They had to invent more efficient ways to do it. That subsampling technique, for example, is a clever way to build training batches to get the most learning done while still staying within those strict privacy math rules.
So they were maximizing efficiency under some pretty severe constraints.
A constant balancing act.
So what does this all mean for you, the listener? Vault Gemma 1B isn't going to top the leaderboards for performance today, but it's a huge baseline.
A really powerful one. It gives the whole community an open methodology and a working model that is genuinely private by design. It's about accelerating safe AI research for everyone.
It really proves that powerful, large-scale, and provably private AI is technically possible.
Which leaves us with a really interesting thought to end on. If Vault Gemma proves this can be done, what's the next big breakthrough needed? Is it in algorithms, data curation, or just raw compute efficiency? What will it take to finally eliminate that utility gap and make a private model completely indistinguishable from its non-private twin?
That feels like the challenge that's going to define the next few years of AI development.